Okay, so we're going to do something really similar to what we did up here. We're going to make both tables at the same time so we don't want to overshoot our answer, right? So let's set up a table for both of these. I'm going to move this up. We got our other one done. That way the people in the back can see. Okay. Most people would start at 0 because that's our start value, right? What's our start value for this equation? What's our start value here? Are those the same? So I need to keep going, right?
Right.
So let's try the next number. What am I going to have here?
15. You'll never hit the number if you keep going on.
Yeah, we're going to get to that. What would I have here? This tells me to go up by 4, right? So if I start at 20, the next number would be 24. Okay, now we're going to stop for a minute. I'm going to scoot this back up. And off to the side, I'm going to draw kind of a sketch here. So these equations, these lines kind of go like this. One's positive and one's negative, right? So if I start here, I'm at 0, and then I'm at 1, and then I'm at 2. Do you see how the lines get closer and closer together as I move towards the solution? So you can see that happening here. 11 and negative 1 are 12 apart. So I'm starting out 12 apart. How far apart are 8 and 2? 6 apart. So I was 12 apart, and now I'm only 6 apart, and then I get to the answer, right? So what's happening is, as I slide along the lines, they're getting closer and closer and closer together until finally they're the same, right? So you should see that happening in your table. We're going to stop right here, though. How far apart are 14 and 20?
6.
6 apart. How far apart are 15 and 24? 6 apart. Now I'm 9 apart. If I keep going, am I going to get to where these cross?
So you're going like this.
Yeah, I'm going this way, right? They're getting further apart. So what do I need to do to get to where they cross?
Backwards, go negative.
I have to go the other way. Otherwise, I'm not going to get to where they cross. So that's the twist with the table strategy that you have to watch for. And you could see that right away. We did just the first 2 numbers, and we can check that, right? But that's something that you need to check for. You need to make sure that I'm moving the correct direction along the lines. The numbers should be getting closer together if I'm moving towards the intersection point. They're getting farther apart. That means I'm going the wrong way, which means I need to reverse my table into the negatives. Otherwise, I'm not going to get to that point where they cross. So let's put a little comment about that so you remember that. And then let's try doing this the other way and see if we can figure out where they cross. So the y values should be getting closer together if you're moving towards the intersection point. So we'll say closer to each other. If not, we need to go the other way. Otherwise, we're moving away from where they meet up, not towards it. So that means we need to go the other way. So a lot of people would still start at the start value, but now instead of going 0, 1, 2, 3, I have to go backwards, right? -1, -2, -3. So we can still track that in a table to keep our work organized. We just need to go backwards the other way so that the numbers actually get closer together. So we know we're starting at 14 here and at 20 here. Let's go backwards. Make sure we can still see our equations. So let's try -1. -1 plus 14 is what? 13. Okay. 4 times -1 plus 20. What's that going to give me? 16. Okay, so now let's check again. So these were 6 apart. Now how far apart are they? 3. Ah, so now I'm moving the correct direction. So now what's happening is my lines are getting closer together, right?
Basically, it's just like
So if I keep going, they're going to meet up,
so it's
right?
just opposite. Like on the top, that one's adding by one, and then that one's subtracting by one.
Yeah.
And that one's-
And it kind of depends upon the combination of equations, what's going to happen. But once you get that first little bit of the table, you should always stop and check and make sure that the y values are getting closer together. Otherwise, you're going to go forever and never get to the answer.
Wait, I thought if you're going back negative, then so since it's going inwards, we're subtracting on the x. and going to
Yeah.
negative on the-
Basically, if you kind of come back to this visual, what this is saying is right now I'm over here. So if I keep going this way, I'm going to get farther apart, right? So if I'm starting here, I have to go backwards because they're crossing basically to the left of where I'm starting.
Okay.
That's why I drew that, so you can kind of see the visual of what's happening on the graph.
Yeah.
Okay, so let's keep going. We're not there yet, but let's see if we can get there and actually find the answer. We know they're getting closer together. If they're getting closer together, that means they're going to meet up. So let's try negative 2. What's negative 2 plus 14? 12. Okay, 4 times negative 2 plus 20.
12.
Oh, hey, woo, there it is. So these cross over in the negatives at negative 2, 12. That's your answer.
Wait, is it ever possible that they couldn't be the same as the positives or the negatives?
So that there be more than one answer?
No, like, say if like you said that if they're just the y's are getting farther apart when you're like adding, like going by positives, you know, and then if you go negatives, they should like come together. But what if they don't? What if they can't?
Yeah, if they're parallel, that would be no solution, right? What you would see happening if they're parallel, if the lines are parallel, they never get closer together or farther apart, right? So if they were parallel, the y's would always be the same distance apart. So they would always be like 6 apart or 4 apart or whatever it is. If you're comparing the y's and they're getting closer together or farther apart, then you know that the lines are going at 2 different angles and they're going to meet somewhere. You just have to make sure you go the right way to find where they meet up.
But what if the lines are going like this?
Then the y's would never get, so like here, see how these are changing? They're 6 apart and then they're 3 apart. If they were parallel, they would be 6 apart and the next one would still be 6 apart. They wouldn't change because the distance between them never gets different or is never different on the graph.